All right, hello again, grade mighty tens. Okay, I hope you're well. I hope you're good. Grade mighty tens, guys. Yesterday with the grade mighty tens, because it's you who is in focus right now. So yesterday with the grade mighty tens, I did this. I did trig functions. Okay, my grade mighty 12s. I think I'll be having a session with the grade mighty 12s as soon as I'm done with this live. So this live is about to start. It's a grade 10 live, grade 10, grade 10, grade 10. Calling on all grade 10 learners that were here yesterday when we did trig functions. We started trig functions yesterday with the grade 10s. So this is a call to the mighty grade 10 learners. I'm sorry if I'm disappointing you and you thought maybe it was a grade 9 lesson or grade 8 lesson. No, it's a grade 10 lesson, guys. And I just want to do some revision of trigonometric graphs with them. We did some yesterday where we looked at these two beautiful graphs here. All right. And we were able to lay out a lot of things and establish a lot of things yesterday, which I think were very important. So today we are going to move from question 1 because we answered question 1 and there was a lot of things that we were able to also explain where trig graphs are concerned. All right, so please share the live with any grade 10 learner that might need to be here. Today we're going to go over to question 2. All right, question 2 of trig graphs. And I know it's late, guys. It's late indeed. I understand it's very late, but yeah, this is the only time I could avail myself. So we looked at this yesterday, part 1, all right, question 1, and we answered thoroughly all these questions. All right, I'm not going to repeat this because this is done and dusted. This is behind us. Today we are just going to slowly but surely move on to this question, and hopefully as we answer the question, if there is anything that you want clarity on, I kindly invite you that in the comment section, you use that comment section very wisely and you ask any questions that you want. All right. So I hope you grade 10s as we start this lesson now, as we start it, because we are only starting now. You can make sure that you have everything in order. Okay. Slow down, sir. We are still taking our material. All right, let me give you a chance then to take your material. All right, grade 10 learners. We already looked at this. This I'm not going to repeat. Okay, already looked at this. The function f of x, which was there. All right, which was this function, the cos graph, the mother cos graph. Okay, so I'm just going over what we did yesterday. I'm not going to answer what we did yesterday, just going over it so I can buy some time for those who still need to get their material and all of that stuff. So we looked at this graph, all right, the cos graph. Then we sketched g of x, which was 2 sine x. And when we did, it was very simple. We substituted 0, we substituted 90, we substituted 180, we substituted 270, we substituted 360 so that we could see exactly how this function rolls. All right, and we sketched it and it was nicely sketched. We were asked to find the period of f, which obviously is the cos graph, and we established that the period is 360 degrees. We were asked to write down the amplitude of g, which was this function, and obviously that amplitude of g, we were able to establish yesterday that if we want to calculate amplitude, we use a formula. Amplitude is equal to the maximum minus the minimum, which we divide by 2. And then we are able to find what the amplitude is. It is actually 2, okay? Positive 2, because amplitude is always a positive value, okay? Then we were able to find the range of the function, okay? The range of g, which means this function. And we know that the range, we established what the range was yesterday. We said range by definition is the possible y values where the function exists from bottom to the top. So we we're very clear that range has to be measured as that region where the function exists, and we look at it from the bottom up. Okay, so then we were able to establish that this function y is equal to 2x has the range, okay, which is y is an element of negative 2 to 2. Okay, so guys, what I'm doing here is I'm just going over what we did yesterday. I'm not delving into anything new. I'm just buying time for those that need to gather their material and be here. Okay, remember that what I'm doing here is something that you can actually go and check out on my channel if you want. Okay, you can go and check it out in the channel, because we answered all these questions and it was nicely answered, these questions. I feel like there was a lot that we learned yesterday when it comes to these questions. So I'm just buying some time so that those who need to be here settled with their material can be here settled with their material, and I can start. So I'm giving people that opportunity. At 9:20, I'm going to kick off in the new section that I wanted to look at for today, for trig functions. So this is for grade 10s specifically, because the grade 10 learners, I have not given them equal time on the live, right? Even though my grade 10s, I feel like they don't give me that thing here in the live. Very quiet and whatever. Yeah. Okay, so anyways, we looked, so the range there for this function, remember this one, the y is equal to 2 sine x, g of x, which is 2 sine x. The range for this function, we're looking from the bottom all the way to the top. So we are checking where does the function exist from the bottom to the top. So when you move from the bottom, you can see the lowest value that the function exists at is y is equal to -2. There, you see, and you can see there the function does exist. It turns at that point. So that's why we say y is an element, and when we write that element, we write square brackets to show that the -2, we including that -2 as part of our answer. So from -2, the function exists, and look at it, it goes all the way to what? Look at the highest point that the function reaches, it's +2. So the y values where the function exists is from -2, and you can see most, it's existing, it's there to the top. So from the lowest to the top, it is y is an element from -2, then this semicolon just means to 2. So it's -2 to 2. And then we close the bracket, you see? So that's the range of this function. Okay, the range of this one. Same way, if we were asked what's the range of f, guys, what we would do is we'd look from the bottom to the top, where does the function exist? So I'm sure you see at the bottom, the lowest point of this function is -1. The highest point of this function is +1. So if we were writing the range of this function, this one, f, we would say y is an element of what? Square brackets from -1 to 1. So every time, guys, we write the range, we write from the smallest point, the lowest point of y, to the highest point of y. That's what we talk about when we talk about the range, where the function exists, all right, for all y values, for the y values. So it's from -1, you can see -1, all the way to what? To +1. It does not go higher than +1, it doesn't go lower than -1. So that's where it exists. Okay. Then we looked at these questions. Remember these ones? For which values of x is f of x less than 0? We explained this, that f obviously refers to the to the cos function. That's f of x. The cos function is f of x, right? Now they are asking for which values of x is f of x, meaning where is this function? Now this less than, what does it mean? I explained yesterday that this less than means below, underneath. Where is this function underneath 0? where is this function below 0? Where is this function underneath 0? And remember, I explained that this 0 means the y value, which is equal to 0. In other words, the line y is equal to 0 is the x-axis. So we are asking, in other words, where is this function? Which function? This one. Where is it below or underneath the x-axis? That's what we are asking, in other words. Okay, so this is 0 value here stands for our output, which means y. So we are asking, where is the function below the x-axis, in other words. So if we check here, we can see the function from 0 to 90, it's above the x-axis. It's above. It's on top of the x-axis, all the way from 0 to 90. At 90, it is on the x-axis. But then from 90 to 270, look at the function. Where is it? It is now underneath. It is below what axis? The x-axis. In other words, it's below the line y is equal to 0. That is what we are looking for. We are looking for where the function is below the x-axis. In other words, the line y is equal to 0. So which x values show us the function being below? You know, it is from 90 to 270. Does that remember the song Inspired by Dawn? No. Let's leave that song. That song was for the people that were here yesterday. Good for you. I'm glad that you understand, you remember that song. You know, the one, I'm going down, I'm going dawn, I'm going down, dawn. Yeah, that one. Who can forget that song? It was a classic. So indeed, below the x-axis means from 90 to 270. But remember, we don't include 90 because at 90 exactly, the function is not below the x-axis. It is on the x-axis. We are not looking for where it is on. At 270, it's also on the x-axis. We are not looking for where it is on. We are just looking for where the function is below. So it is between 90 and 270. In other words, between. Okay, so that's why we say x is an element. We use open brackets. That's what helps us to say we are not including 90. And we use open brackets at the end. That is to say we are not including 270. We are just saying between 90 and 270. This is the answer for this question. So I repeat, what are we saying? Where is f below? Where is f underneath? So you go and locate the function first. So what you must do is you must always go and identify this function. Okay, first go and see who are they talking about. And who are they talking about? They are talking about him. And then after identifying who they are talking about, what is this less than saying? It is saying below. Below who? Below the x-axis. Are you with me? Below the x-axis. So then now we can say, okay, in this function, where is the region or the interval where this function is below the x-axis? We can clearly see it is from 90 to 270. You see that? Okay, guys, I hope you are really seeing that. It is from 90 to 270, between 90 and 270. 90 is not included because at 90 it is on the x-axis. At 270 it is also on the x-axis. So we are not worried about exactly at 90 and exactly at 270. We are worried about in between, and in between is where our answer is. So we say x is an element. We write our answer in what I call interval notation. We say open brackets to show that 90 and 270 are not included, and then we say from 90 to 270. That's it. Had the question been phrased differently, as less than or equal to, then obviously we would say where is the function below, which means less than, and equal means on. So we are looking at two things now. We are looking at where is the function below and on the what? Remember, this 0 means the line y is equal to 0, which is the what? The x-axis. So we are saying, where is this function below? That's the less than part. And the equal part means, where is it also on the x-axis? So if we go back to the same picture, this time round, from 90 to 270, at 90, the function is on the x-axis. At 270, the function is also on the x-axis, which means these values now need to be included, okay, as part of the interval answer that shows that the function is what? On the x-axis. Then for below, where is the function below the x-axis? It is between these two values. So now when we write the answer, we say x is an element. We no longer use open brackets, but we use square brackets or closed brackets for both sides, because for both 90 and 270, the function is on the x-axis, and then between 90 to 270, the function is below the x-axis. Okay, I hope that's clear for all of you. And guys, if we change the question and we say, for which values of x is g of x? Yes, J, R, Clate, Rain. What do you want to ask? Go ahead, ask. Ask, don't delay. J, R, Clate, Rain. Is it raining there, Mr. Rain? Ask your question, shoot your shot, and then so we can proceed. Yes, what's your question?
So if I say x is less than or equal to 90 and greater than or equal to 270, am I wrong?
Repeat what you are saying again, so I can write it down. You are saying x is? X, yes?
X is less than or equal to.
Okay, to what?
On the left, equal to 90.
On the left? Less than or equal to 90?
Yeah.
So, do you mean in this direction, less than or equal to 90?
Yes.
And then where's the 90?
On the left.
On the left, okay.
And greater than or equal to 270 on the right.
Okay, so you mean this greater than or equal like this?
Yes.
So 90, is this what you mean?
Yes.
Okay. Now I want you to read what you are saying again. You are saying x is, say it. X is?
X is less than or equal to 90.
Be careful.
Greater than
Be careful. Let's go back. I want you to read this again. You are saying x is what?
Is less than or equal to.
Are you
90.
sure? Okay. If you are saying x is less than or equal to 90, I want you to understand what you are saying. You are saying to me, if you are saying this is how you're reading this, okay? That's why I wanted to be sure. What sign do you mean? Okay. I'm sure you wanted to say this.
Oh, no.
This is what you want to say, right? This is what you wanted to write. Okay. Because when we read this, if you are saying x, then you are saying x is greater than or equal to 90, but less than or equal to 270.
Equal to 270. Yes, I wanted to say that.
I needed you to be sure about what you see and what you mean by what you see and what you are saying. Because you see, the thing is, many times learners don't actually understand what they are writing down. Maybe they know what they want to write, but then it's like I don't know what happens. So for instance, I oftentimes see my learners do this as well. And this is so wrong.
Yes.
This is so wrong.
Yes.
They want to say, in other words, that x lies between 90 and 270. They want to say that, right? X lies between 90 and 270, but At 90, it's included. At 270, it's included. But please, this is how you read this. This is the correct answer, this one. You are saying
Oh,
X, okay? Since this
yes.
symbol, you are reading from left to, you are reading from right to left. We say X is greater than or
Yes.
equal to 90,
Greater than equal to 90.
but less than or equal to 270.
270.
Yeah.
Oh,
Okay.
now I see.
So yes, you
Thank
can
you,
write
sir.
your answer in this way. This is called inequality form. So you can write your answer in inequality form instead of writing it in interval notation. That's fine.
Oh, yes. Thank you, sir. Thank
But
you.
please write what you mean, eh?
Yes.
Yeah, yeah. Otherwise, no problem with that. That's good on you. Okay, I think that's clarified. That's fine. Okay, yeah, you can definitely do that. This answer here can, if you want to, you can write it in this way. Say x is greater than or equal to 90, but less than or equal to 270. Okay, you have two ways in which you can write your answer for this particular question. You can either write your answer in interval notation, or you can write it in inequality form. Now, I usually say to my learners that if you need to decide which way seems to be more appropriate for you, and then you need to stick to that and consistently write your answers in that way. Okay. So I hope that's fine. Yes, Lerato, it will obviously be posted there, don't worry. Okay, let's move on. G of x, I'm sorry about what came up, by the way. G of x less than 0. Obviously, if we're talking about g of x less than 0, then we're changing our focus to the sine graph, this function, by this function, okay? Now, what are we saying still? We are saying where is g below 0? In other words, where is g below the x-axis? So once again, what are we doing? We're going to go through our function. We are going to check where is this function below the x-axis. And I'm sure you guys can see this is where the function is below the x-axis. From who? From 180 to 360. But of course, we were not told on equal to 0. We are just asked where is it below. So then that means x is an element of 180 to 360. And that pretty much is it. Okay? And we use open brackets. You could write your answer in inequality form as well, right? And you could say 180, you can say x is greater than 180, but less than 360. You could write your answer in this way as well. That's fine. And remember, because we are not including our endpoints, we write obviously in inequality form. Okay. J.R. Clayt Rain, I've actually done grade 11 trig 2D. All right. It's done and dusted. But what you can do if you want, you can check out the live session that I did on that section in my YouTube channel. The link is in my bio. You can, I'm sure you'll see it. There are videos that have been posted not so long ago. They have a purple thumbnail, and they are written there. There's a part 1 of like trig, area rule, sine rule, and cosine rule, because that's what you're talking about, right? And I did like the rules. We looked at the conditions. We did how to find sides and angles for applying the sine rule, applying the area rule, and applying the cosine rule. And we looked at variable type questions as well. So you can always check that out. Then let's look at C. Grade statistics grade 11 is still coming up, because I understand that some learners started with statistics towards the end of the week last week. Some of the learners are only starting with stats this coming week. So this coming week, I will do some stats for you. I have things lined up, so don't worry. That's still coming up. Okay. Then here, number C, where is G? Is G increasing? That was the question. So if we look at the function, I explained this whole increasing and decreasing notion of functions. So if we look at G, we said the function is going up here, then it goes down, so it's decreasing all the way, then it goes up again. So the function here has points or intervals where it's increasing. And that's what we want to identify. Okay. In Essentia, financial maths will follow after statistics. Okay. So all these grade 11 topics that you guys are mentioning here, statistics will, financial maths will follow after statistics. Or I might just do it in another live, to sort of like start it out. Probability, on the other hand, I've already done grade 11 probability. Also on my YouTube channel, if you can check out, I've done probably 4 or 5 videos on probability. I started it out with the grade 10, and then went up slowly but surely with the grade 11. Okay. Yeah. So at the moment, we are busy with trig function graphs. And so if you're saying do functions and graph, the question is, what grade are you talking about? Okay. EU statistics grade 10 is basically when I do grade 11 statistics, I'll start with the foundation of grade 10 stats, of course. I've also done functions for grade 11 YouTube channel as well. I think there are live sessions that I've done and videos that I've uploaded there, but at a future time we'll do those again. Okay, now 1.6, sorry, number C, G is increasing. Where is G increasing? G is increasing from 0 to 90. Okay, yeah, 0 to 90. Sentia Mukai, the grade 12 learners have also been doing basics for the past few weeks. That's something that I've been doing. So once again, if you go to my link, guys, the link is in my bio for the YouTube channel. Go and find the series of videos. They were very long. Like we did cross night sessions with the grade 12s a few weeks back. So like the videos are very long, like 3 hours, some of them 2 hours, because we did question 1 type questions with the grade 12s. We did sequence and series type questions with the grade 12s. We did nature of roots. We tried to unpack question 1 with a variety of questions that tend to be there from different provinces, different trial papers that have been written in the past. So I did that with the grade 12s. You can find some of the videos that I did with that, the full live sessions. They're quite long though. On my YouTube channel, they are there and you can check them out. Quality probably not as great because these are like literally the videos that I'm uploading from the live sessions as you see them. A lot of moving around, a lot of talking, but I would suggest that you use that speed option that you have that's available, like to sort of like go through, the introductory part and get to the meat of the content. Okay. Unfortunately, now I'm busy with grade 10. So guys, if you want to message me specifically pertaining to something, please feel free to message me and send an inbox message. I'd be happy to actually follow up on anything that you would like to ask me about. Okay. Yeah. But for now, it's this. And shortly after I'm done with this session, I'll be doing a session with the grade 12s, continuing on with calculus, because we started calculus yesterday. And this is like me continuing on from what we had been doing, because we like I said, we went through question 1 type questions, question 2 type questions, question 3 type questions, question 4 type questions, question 5 type questions from previous papers, previous trial papers. So now we are busy. We are at calculus, and we started calculus yesterday, and we did a bit of cubic graphs. So I was gonna go back again and do some more, maybe a bit harder questions on calculus and cubic graphs, and we'll take it from there. Guys, I'm taking time from the grade 10s. Now, if we look at this, is G increasing? So we specifically said that G is increasing from 0 to 90. That's where the graph is going up, right? So that's why we say from 0 to 90, there's an increase. But you can see, guys, from 90 all the way to 270, there's a big decrease that's happening here. And then again, from 90 to 270, to 360, there's an increase again. So it's very important to note the intervals where the function is. Look, from 0 to 90, these x values, look at the increase. Then from 90 to 270, look at the decrease. Then from 270 to 360, look at the increase. You see? So hence, when we wrote down the intervals, we said x is an element of 0 to 90, or x is an element of 270 to 360. That's where G is what? increasing. Okay. Then 1.1.6. If the graph of G moves upwards by 1 unit, write down the equation of the new graph. So I repeat, if the graph of G, now where is G? G is G of x is equal to 2 sine x. Now all of a sudden we're being asked if the graph of G moves upwards by 1 unit, we need to write down the equation of the new graph. So we explained yesterday that when we speak about upward movement, this is affecting our parameter or our Q value, because this is the standard form of a sine graph in grade 10. Okay, in grade 10, we only deal with the sine graph insofar as the coefficient of the sine graph and the Q value, which is the constant. That's all, because our function is only doing two things. It's either vertically stretching or compressing, or it is moving up, meaning it's vertically moving up when Q is greater than 0, or when Q is less than 0, it is vertically moving down. So it's shift up or shift down. So that is basically the only thing that we are concerned about, okay, when it comes to that particular function. So yeah, I under Escomede, you can say Cela accept a request that comes with you are someone who has are you joining my live session for the first time? Okay, yeah, because I think there's, yeah, I need to establish that. And then Tando, the whole including or not including for increasing or decreasing, we spoke about that. Okay, and we said that amongst examiners, okay, if you write your answer with open brackets or closed brackets, either or, the answer will be accepted, because there is an argument, obviously, and the argument is that since that is a stationary point, you know, do we include that point or don't we? So yeah, whether you include it or don't, it doesn't matter, all right? Especially pertaining to our syllabus within caps, it doesn't matter. So if you include it, you'll be marked correctly. If you don't include it, you will be marked correctly. So either way, it is okay to include or not include the stationary point or the turning point, as you would call it. So whether you include it or you don't, you'll be marked correctly, because the consensus that has been accepted generally, even at national level, when they are marking exam papers during your final end of year grade 12 exam, is that whether that is included or not, currently we embrace or we accept it and embrace it. It is correct. Okay, that's in the midst of an argument that has been happening for the longest time. The consensus that has been reached is that whether you include it or you don't, it's fine for where the graph is increasing or decreasing. Okay, so I decided to include it, but if you had decided to not include it, you'd still be 100% correct. Okay, I hope that's fine. I explained that yesterday in the live session, so that's why you've seen me sort of like not really stay there for too long. Okay, now let's go to this guy, because Mr. Kumede there, yeah, I guess connection is at fault your side, because that actually went on for a while, but it didn't take it. Okay, let's come here, guys. This is what we're going to look at today, and then we'll call it a night with the grade 10s, because I know some of you have a curfew and your parents wouldn't be happy having you up and awake at this time of the night. So let's look at question 2. The diagram below shows the graph of f of x is equal to tan x. Now this is good, because when we were looking at the previous question, we only saw a situation of sine graph and a situation of cos graph. So now we have the opportunity to investigate and look at the tan graph. So we are told that the graph below shows the graph of f of x is equal to tan x for x is an element of 0 to 360. So the function is sketched in this domain. Okay, domain meaning the possible x values, which in this situation the function is allowed to exist. From 0, let's just investigate and look at how the x values are progressing. So we have 0, 45, 90, 135, 180, 225, 270, 315, and 360. And that's basically the point at which the function is allowed to exist, from 0 to 360. So I'm sure you can see, guys, how the function is. And when you look at it, if you are someone who has been able to be exposed to the mother graph of the tan graph, which this is the mother tan graph. It's the mother. Guys, you know the mother. The mother is the source of everything. Okay. So when we look at the tan graph, we know that this is the mother tan graph. So let us see what questions do they have for us with regards to this tan graph. So 2.1.1 says, sketch on the same axis the graph of f of x is equal to negative 3 cos x for the same interval from 0 to 360. Okay, so we are asked now to sketch what? Negative 3 cos x. And so honestly, what I'm going to do to make life easy for myself, I'm going to go to my calculator, which is really gone through the most in life. You can see it's really rogue and beat up. But you know what? It serves the purpose, okay? Because I'm one who's been giving away a lot of my personal calculators to my students. And now I'm just left with, the scraps, if you want to call it that way. So we can go here and say mode, all right? And then we go and select table for 3. And there we have it, f of x. Now we need negative 3 cos x. So all we do is we say minus, and then we press 3. And then we follow that with cos. And then since we want x as well, we say alpha, because that allows us to select all the red things that are in our calculator. So we want the x there that's in red. We press that. There it is. And then we basically use the brackets and we close it up. So this is negative 3 cos x, the function that we want to have represented. So we're going to say equal. Now, if we basically had another function to sketch, we would basically also include it here and we would type it, but we don't have one, so we're just gonna press equal so that we can move on to the next thing. Now we are asked here to start. The start is where we begin. Okay, which x value are we beginning at? So we are beginning at 0 because we are asked to sketch a function from 0 to 360. So let's go ahead and say 0, then equal. Then they're asking us, where are we going to end? So the function starts at 0, it ends at 360, so we are going to end where? 360. Okay, and then say equal. You see this 5? I'm sure it's going to be safely removed. It's no longer 5. Then what is the step? Our step is the increase, okay, from 0 to 45. So we are going up by how much each time? By 45 degrees, because 0 to 45 is 45 degrees. 45 to 90 is another 45 degrees, which means our step is 45 degrees. So I'm going to come here and place and type in, after the step appeared, I'm going to press in 45. Then I'm going to say equal. Okay. Now, guys, what you see here is the corresponding when the x value is 0. You see? My corresponding y value is negative 3. Do you see that? This here makes life so easy for me. All I do is I go up and down and I check what all my x values give me when I substitute what are the corresponding y values. So when I substitute 0, I get y, which is negative 3. That's why you have x. This is for all the x values, 0, 45, 90, and so forth. The corresponding value f of x, you see, which is, remember, f of x stands for y. Okay, so when x is 0, y is negative 3. When x is 45, y is that. When x is 90, y is this. So I'm going to mark all of these points on my graph. So let's go. When x is 0, that's there, y is negative 3. So that's where my function is going to start. Then when x is 45, y is negative 2,121. Now guys, I'm going to do an estimate here. Okay, when x is 45, y is negative 2,121. So these lines there, I feel like this is 2,1. So I'm going to slightly have that point there, just a little bit below 2,1. That's the point. X is 90. Okay. X is 90. The y value here is going to be 0. Okay. Okay, Kevin Russell, I don't know if you're spamming here or what, but my brother, I'm sorry. I think you're going to have to go and spread the word faith elsewhere, please. Because I don't know if you guys, I just hate spammers. People come here and they do all sorts of things. Yeah, I'm all for faith, but I think more than anything else, I hate people that come and spam. Me live, I do. Okay, so when x is 90, y is 0. So when x is 90, we are at 0 there. Okay. Then we go down. Let's go and look at the other values. See, x is 135, y is 2,121. So x is 135, y is 2,1. So we slightly there. Okay. Seems like we're moving. X is 180. Right? Y is 3. So 3 is there. Okay, I think we are making some progress. Let's go down. X is 225. Corresponding y value is 2,12. So once again, we are back here. Then we go down. X is 270. Y is 0. So x is 270, y is 0 there. Going down, x is 315. The corresponding y value is negative 2,121. So 315, 2,121. And then lastly, when x is 360, we've got a y value which is negative 3. So x is 360, y value which is negative 3. Okay. Okay, I'd say that's a nice. Okay, do you see that, guys? There it is. Okay. And what I do is I label the points. 315 and 2,12. Okay, that's 270. That's fine because it's on the x-axis. That will be 225 and 2,12. That's negative 2,12. Sorry. Then that is 3. That's 180 and 3. And that is 135 and 2,12. That is 90 and 0. Of course, that is 45 and 2,12. And then lastly, beautiful one, 0 and 3. And then we can label that function and say that is f of x is equal to negative 3 cos x. Right, there it is. Function sketched. Okay, on the same system of axes. All right. Okay, I hope you guys have found that satisfying. So this is how helpful this Mr. Calculator is. Let's move on to the next question. Write down the period of f. Okay, can someone tell me what the period of f is? The period of f, remember f is the tan graph. So what is the period of f? Let's see if people know their stuff. The tan graph has a unique period. Cos has the period 360 degrees. Sine has the period 360 degrees. We're speaking within the grade 10 context. And in grade 10, guys, your period in grade 10, for sine and cos, it's always 360. Okay? But then grade 10 is just like that. And then the tan graph in grade 10 is also consistently. So I can see 790 light, it says 180 degrees. Tan.2 as well says 180 degrees. So you guys are spot on. Yes, the period of f, indeed, guys, the tan graph is going to be 180 degrees. Okay, you guys are 100% spot on. Let's move on to the next question. Write down the amplitude of G. Okay, I think, guys, G was meant to be our cos graph. So let us fix what is basically wrong here, because our f was already given to us. It's the tan graph, but then our cos graph is G. Now they want us to write down the amplitude of G. So what is the amplitude of G? Okay, we are not asked to calculate it, but we are asked to write it down. So what is the amplitude of G? Meaning, what is the amplitude of this function? Do we know? So guys, what we know as well is that the amplitude is a distance, right? So any distance is not going to be negative. Any distance is going to be positive, all right? And something that we know where the sine and the cos graph is concerned, whenever we want to write down the amplitude of the sine or the cos graph, okay, and this is only the sine and the cos graph, you must look at the coefficient of the function. So in this case, it's actually -3. But of course, when we write down the amplitude, we are going to ignore the negative sign. We are going to ignore the negative sign because remember, amplitude is a distance from the position of rest of the function to its maximum. So in this situation, the distance cannot be -3. Hence, I'm saying the coefficient of the function, which in this case is -3, all right, ignoring its sign will actually give us the amplitude. So Lunga Lubelo, you're 100%, and Tando2, you guys are 100%. The amplitude is equal to 3. We ignore the negative sign to write down the amplitude of the sine or the cos graph. Guys, it's only the sine and the cos graph where we write down the amplitude, ignoring the sign. I want to ask another question. Let's say they had asked, what is the period of the cos graph? What would we have said? What is the period of the cos graph? I want to ask this. This graph, g of x, which is -3 cos x, what would have been the period? I want to ask you that. Period of g. Can someone tell me what the period of g is? Yes, Sivenati, very good. 360 degrees. Lunga Lubelo, you're 100%. The sign is for the shape, definitely. Okay. The sign is for the shape. Okay. Yes, guys, you guys are 100%. The period of G is 360 degrees. I love it. You guys are brilliant. You guys are intelligent. Now I want to ask this question. What is the amplitude of G? I mean, not the amplitude of G, the amplitude of F. What is the amplitude of F? The tan graph. Okay, can you guys comment in the comment section? What is the amplitude of F? What is the amplitude of F? Neo RSA, I've already sketched. I don't understand why you'd say, can you sketch after? Please. What is the amplitude of F? Okay, now I will see if you guys have an understanding or a misunderstanding about the tan graph. Because I had a learner in my grade 10 group that actually was, very what you might say, she was very confused, okay, because apparently what she had learned from her teacher was that the tan graph, especially the mother tan graph, this is the mother tan graph, the teacher had said the amplitude is 1, all right? And I'm sure you guys can sort of like probably understand why maybe someone would say that the amplitude of the tan graph is 1, okay? Remember, when I asked you about the amplitude of G, if you remember very well, I said the amplitude of G is going to be the value of the coefficient, but we ignore the sign, okay? Because we are always going to be taking the amplitude, the coefficient, not the amplitude. We are always going to be taking the coefficient of the trig graph, but that's only for sine and cos. Only for sine and cos, not for tan. Only for sine and cos, we take the coefficient of the given trig graph function, but then we ignore the sign because amplitude is always a positive value. So hence we said the amplitude of the graph of G is positive 3. Now someone else may go ahead and apply the very same thinking, which is not going to be true and relevant for the tan graph. Now you are going to ask why. Guys, the tan graph has no amplitude. The tan graph has no amplitude, and that's very important to note. The tan graph has no amplitude. So this graph here, okay, does not have a amplitude. All right, you will remember very well that when we spoke about amplitude as well, and we spoke about the formula that we use to calculate amplitude, we said we take the maximum and we subtract the minimum and we divide by 2. My question then is, what is the maximum value of this tan graph? Remember that the tan graph goes on infinitely, okay, never stops, does not touch something called the asymptote, the vertical one, but it goes infinitely in that direction. So the maximum is not there. It has no maximum, okay? And then the minimum, once again as well, goes down forever infinitely, have no maximum, has no minimum. So if there's no maximum or minimum, how can we subtract a maximum and a minimum in the numerator and then expect to divide by 2? So for the tan graph, we must please note that there is no amplitude. So don't ever say that the amplitude is given by the coefficient of the trig graph. Okay. So I hope that's clear for us. Okay, we don't ever say that. That is not the amplitude. Okay. Okay. So I hope that's noted as well. Thank you. All right. PVT Life, I see you. Sure. Write down the range of G. Okay. Now G, remember, is which function? It is the cos graph. So what is the range of G? Do you remember what we said about range? Range is the possible y values where the function exists from the bottom to the top. So what's the lowest point that the G graph reaches? And what is the highest point that the G graph reaches? And is it available in between the highest and the lowest point? We start from the lowest to the highest. So what is the range of G? Ditiro, let's all, very good. Hey, Ditiro there. Ditiro, are you in grade 10? Are you sure? Let's all. Is it let's all? Are you in grade 10, my little? See you answering there. Maybe you are in another grade, Here to eat the kiddies' snacks here. KMLORSA, that's true. Definitely true. Okay, so I love that the guys are writing there their close brackets. Okay, because at -3, which is the lowest point, the function exists. I just love math. Okay, and the highest point is +3. So right, you guys are 100% spot on. The range is y is an element, square bracket, from -3. We include -3 all the way to +3. So that is the range of G. 100% spot on. Okay, guys, let's move on to 2.1.5. For which value of x is f of x less than 0? Now remember, who is f? F is the tan graph. Now we are asking, where is this function? Remember, what did we say less than means? It means below or underneath. But below what? Or underneath what? 0. What does this 0 mean? It means the line y is equal to 0. In other words, the x-axis. We want to know, where is this function, the tan graph, where is it below the x-axis? All right, so let's go and look at the tan graph. Here is the tan graph. We are above here. Here we are above. Here is the tan graph. We are currently below. Till here we are below, and then we continue to be above. So there is, from a certain point to a certain point, we are below. That point, to that point, we are below. But from here to that point, we are above. Look at from here to there, we are below. All right. So the intervals where we are below is where specifically? For who? For tan. Who is tan? There is tan, there is tan, there is tan. Where are we below? From 90 to 180. Do we include 90? No, we don't, because it is on the x-axis, and in actual fact, at 90 we have an asymptote for the for the tan graph. So that means we do not include 90, but between 90 and 180, do we include 180? No, we don't. Why don't we include 180? Because at 180 it is on the x-axis. Okay, so Vienna, you are 100% correct. Vienna, Vienna, Vienna. Man, are we eating Vienna? Are we going to eat Vienna, my Elita? No, Lunga Lubelo. That's not correct. You can't say from 180 to negative infinity. No. Very wrong. Very wrong. This here, it is as wrong as can be. Okay, and I don't mean to embarrass you there, Lunga Lubelo, but if you're going to write that, you are going to get 0 marks. Okay, you're actually going to lose everything. So please, guys, let's check where the function is what? Where the function is below. All right, from 90, guys. Okay, from 90 to 180. Do you see? Look at it. Here's the function. Okay, it will continue being below, right? But it will be limited. Okay, because in a tan graph, we know that the line x is equal to 90 degrees has something that we call the what? We call it the asymptote, the vertical asymptote. What does the vertical asymptote do? It basically limits the function from actually going beyond this line, right? So it will approach that line, but it will never touch it. Okay, so that's very important to note. So from 90 to 180, the function is below. It's going to be below from 90 to 180. At 90, it's not going to be included there. At 180, it's not going to be included as well, because at 180, the y value is 0, right? It's not negative. Here, at 90, the function does not exist. Okay, the tan graph does not exist at all. But in between, the function is negative. Okay, so from 90 to 180, we have an answer. Okay, I'm going to write down the answer, but I just need you to understand that from 90 to 180, where both of these are not included, there's an answer. Then, again, you can see here is the function again. It's what? It's negative. But yet again, the line x is 270 is what we refer to as the asymptote. Okay, we have another asymptote, vertical asymptote, at the line x is equal to 270. That's very important, guys. Okay, so the function will not pass through this line. It cannot touch this line. Okay, So the second answer here that we have, yes, Vienna, that's 100% correct there, the way you've written it down. Okay. Yeah. So yes, this function moves closer and closer to the asymptote, but it never touches it. Like it goes closer and closer and closer. It comes extremely close to it, but never ever touches that line. Okay. Yeah. So grade 10s, this is very important because at this foundational stage, if you have a good understanding of trig functions in grade 10, grade 11 and 12 is nothing. Okay. You learn one additional thing in grade 11, which is when the function moves left and right, and when it changes its period, and then that's it. Grade 12, you are basically repeating grade 10 and grade 11, what you learned. And then you should be sorted. I mean, you should really get the marks in functions. And I mean, in a full paper, functions is worth how much? 10 marks? 10 to 11, 12 marks. So this is marks that you should get for sure. Okay, so let's write the answer. We could write it in interval notation and say x is an element, open brackets, 90 to what? 90 to 180. We opened the brackets. So this is one way of writing the answer. Or from where? From 270, we open brackets, to who? To 360. Now at 360, guys, the function is equal to 0. Okay, at 360. So we open the brackets as well. So this is how we would write in interval notation. You could write the answer in interval notation. Or if you don't want to write the answer in interval notation, you could write it and say x is greater than 90 but less than 180. Or x is greater than 270 but less than 360. This is another way of writing the same answer. You're just writing it in inequality form. Okay. Vienna, I prefer this way. That's fine. If you prefer this way, go ahead. Okay. Me, I'm the teacher, so I have to give you both ways so that I can allow you the chance to choose which way is most convenient for you. All right. But remember, there's no need to write it in all these different ways. You just need to write it in one way. We call this interval notation. Interval notation. The top part. Okay, this way of writing the answer. Or if you don't want to write it in interval notation, then you are more than welcome to write your answer in this inequality form. You decide. Okay, you decide which way is most sweet and convenient for you. Okay, I hope we're good. I hope we're well. Can we move on and answer the next question then? Yeah. I know we all prefer various ways. You know, some of us will feel like interval notation, yeah, that's my way. And then some people will be like, no, I love the inequality way of writing the answer. So whatever way flows best with you, you go for it. Have a blast, please. Let me not stop you, and let no one stop you from writing in the way that you want. Okay? You just need to be sure that your teacher knows both ways so that they don't hold you at ransom. If you know what I mean. A donative girl. Okay, a donative girl. What did a donative girl say? Vienna. I wonder why is someone called Vienna. But anyways, B. For which value of x is g of x? For which values of x is g of x less than or equal to 0? Yeah, guys, you never know. You'll get penalized by some individuals. I know what I'm talking about because they don't know that other way. They also know one way. For which values of x is g of x less than or equal to 0? G of x. Where is G of x? Now we are talking about the cost graph. So we are asking, where is that function less than or equal to 0? What are we saying, in other words? What are we looking for? Two things. Two things. Okay. Less than means below. Equal means on. Okay. Yes, Dawn. Of course. I'm so late, I missed out on a lot. No, you can always check it out there. The Dawn. The down Dawn. They actually, like, someone in the live in the comment section a few minutes ago was actually not even a few minutes ago, nearly to the beginning of the live, was like, do you remember your song about going down to the dawn? I think it was like in remembrance of you. They were missing you. G of x less than, below, equal means on, but 0 means on the x-axis. So we are looking for two things here. We are looking for where the function is below the x-axis and where it is on the x-axis. No, so now we are interested where it's on. Whereas here we were not interested where it's on. We were only interested at where it is below. So we're going to look at below and we are going to look at on the x-axis. Okay. So I hope you guys understand that. Okay. And please, guys, this G of x is to specify that we are talking about the cost graph, this function. And yes, G of x means y. Okay. Yeah. It means y, definitely. But remember that they are function of G of x. Is that function less than 0? In other words, where is this function, the cost function, where is it below the x-axis? And where is it equal on the x-axis? So let's go and check. Here we are here to check at below and on. Okay, so look at G of x. Here we are below. Here exactly at 90 we are on. So that means from 0 to 90, we are below, in between, but then at 90 we are on. At 0 we are on as well. So we must include 0 because at 0 we are below. So we must include 0. 0 to 90. That's where our answer lies. From 0 to 90. Let's go on. What's happening from 90 to 180? We are above. What's happening from 180 to 70? We are still above. What's happening at 270? Now we are on the x-axis. So that means we have an answer here. What's happening from 270 all the way to 360? We are all the way below. We must include 360. So you are ready to write the answer? We can write the answer as x is an element. Now, remember, what did we say? 0 to 90. At 0, we are still below. So that means we include 0. Square bracket, 0 degrees. Are we together, guys? Why we are including 0 there? Then, to what? To what? To 90. Because look, we are below, all the way. At 90, the function is now on the x-axis. But remember, because of the equal sign, we also include 90. So we say 90 and we square the brackets. Together, ne? Okay. We include 0, we include 90. We include 0, we include 90. And remember, the reason why we are including 0 is because at 0, the y value is negative, you see? So we must include the 0. Okay, very important there. So that's fine. Then we can say or what? Everywhere in between here, there's no answer. At 270, we are on the x-axis. After 270 all the way to 360, we are below the x-axis. At 360 exactly, we are still below. So we must include 270. We must include 360. So we say 270 include 360 include? All right. Wow. Okay. Or we know that Vienna doesn't particularly like this way of writing the answer. So to accommodate Vienna, Vienna could say 0, x is less than or equal to, x is greater than or equal to 0, but less than or equal to 90, or x is greater than or equal to 270, but less than or equal to 360. That would also be fine. That would be Vienna being marked correctly. Hopefully the teacher knows this way, or whoever will be assessing, so that hence hopefully this person is not a avid fan like I am of the interval notation, that he or she completely doesn't know the inequality form way of doing it. Okay, so yes guys, 270 we include because it's on the x-axis. 360 we also include because the function is negative there at that point, and it's negative everywhere between. So that's why we say x is greater than or equal to 270 but less than or equal to 360. Vienna, what's up with the thinking hard? It can't be equal to 0. Now you are also being lost. Why would we exclude? Why would we exclude? Okay, Vienna, you are being a Vienna now, to be honest. You are now acting like a Vienna, I must say. You are acting like a Vienna, and it's you know, yeah, you are acting like a Vienna right now. When x is equal to 0, y is negative. What are we looking for? We are looking for where the function is below the x-axis. So here, when x is equal to 0, the function is below the x-axis. Yeah, the function is below. It's there. Look at it. The y value is negative 3 even. Okay. Yeah. I think Light, I think Vienna needs to be cooked. It's true. We need to cook him. We need to cook him. I think the best thing is to make Vienna a hot dog. You must just grab a roll right now and just put him inside and chow him. It's time he got chowed. Like that comment, this one. Aye. Vienna, it's fine. I'm glad you made that comment, because seemingly, you know, and look at the confidence. Look at how long it must have taken him to type that comment. It can't be equal to 0, because where x, you know, he's even stating basically the truth, because the only part that's wrong is he's saying it can't be equal to 0. Okay, which is obviously not true. It can be equal to 0, because now let's read what he's saying. Because where x is 0, true, y is negative 3, which is even more reason why we must say it's equal to 0, and we are including that 0. No, we are going to make you hop in the pen right now. We are going to put you inside. It's time to chow you. You need to be chowed. You know, I believe it's chow time for you. Okay. Yeah, so it's fine. I'm glad, Vienna, it's okay. Like, I mean, don't worry. Those are nice mistakes to make, because what's beautiful about what you said the right thing to this. Let's, you know, analyze the statement again. You say it can't be equal to 0. But the thing is, based on what you are, the reason, you are saying because where x is 0, y is minus 3. That's even more reason to say it must be equal to 0. You know, that what you are saying is so true, the later part of it, that it puts a stamp of approval that we must indefinitely say x is 0. We must definitely say so. So can we focus? You are the one that made us. Sometimes it's good to have emphasis points such as this, because some people will only really catch on to what we are meaning by the answers we write when we actually are having a moment where someone actually questions. Okay, so this is not all wrong to be, for you to have said that. It gives us a chance to actually really unpack what we mean by our answer and then to make sense of it, because that's important. Because remember, anything that's less than 0 is actually something that is what? Is negative. So when x is 0, the y value is actually negative, which satisfies this condition. Because anything that's below 0, it's negative. Okay? I think Dawn is having a field of a time with that comment now. Okay, let's go here now. Is G decreasing? Is G decreasing? All right, that's the question. Now, obviously, there are parts where we can say no, but there are parts where we can say yes. So let's check where we can say yes, the function is decreasing. Let's go and check out the function of G, which is this function. So what's happening here? The function is increasing, increasing, increasing. All right. So definitely no, the function is not decreasing here from 0 to 180. But what's happening after? From 180 all the way to 360. So from 180 to 360, what's happening? There's a decrease. So that means we can actually validate and say, yes, G decreases in the interval. And then you can say x is an element of, then you can say from 180 to what? To 360. And there we have it. Okay. Yeah. Okay. And then obviously you know that in the other interval, which is from 0 to 180, the function is actually increasing. But we wanted to actually underscore the decreasing part of the function. So yes, G decreases in the interval. X is an element 180 to 360. Or if you want to write the answer as per Dawn vibes, I mean, not Dawn vibes, but Vienna vibes, then of course you put the Vienna in the frying pan, and you can actually have a field of a day. Okay. Now, what I did say initially to the learners is that at the turning point, we can choose not to include, right? Or we can include it. It's really up to you. But I think, of course, here, right, at this point, once again, we are about to turn. So obviously, in the turning point, you can choose to include or not include. So whether you write equal, all right, or less than alone is fine. Okay. Okay. Because for decreasing and increasing, that turning point or stationary point, we can choose to include it or not include it on the basis of what we are basically accepting or embracing. Okay. Then 2.1.6 is the graph of G if the graph of G moves downwards by 1 unit. Remember last time we said if the graph of G moves upwards by 1 unit. Now this time around we are saying if the graph of G moves downwards by, write down the equation of the new graph. Who is G? There is G. Guys, if this graph of G moves downwards, please give me the new function. What's the new function? The comment section is yours to populate and let me know what you think. Moves downwards. If this function moves downwards, what's the new function of G? Or is my, because sometimes my filter doesn't allow people to comment certain things. Are you guys having a problem commenting in the comment section because the filter is not the filtering of comments is happening? Okay, PK. Oh wow, PK. I think it's the first time I'm hearing from PK in the comment section. PK, have you been around or you just joined? Because if you've been around, then thank you for finally saying something. But if you've just joined and you just gave us your answer just like that, then it means you just know your maths, don't you? PK, if the graph of G moves downwards by 1 unit, write down the equation of the new graph. And which grade are you in, PK? If the graph of G moves downwards by 1 unit, write down the equation of the new graph. So this is G of X. It's negative 3 cos X. Or you're in grade 10, PK. Nice. Okay, you just joined a grade 10 live lesson then. Way to go. All right, and it's actually coming to an end. Okay, very shortly, because this is the last question that we are doing. So if G of X minus 3 cos X moves downwards by 1 unit, write down the equation of the new graph. So of course the equation of the new graph, guys, would be negative 3 cos X minus 1. To move down by 1 means we subtract from the function negative 1. Okay, we subtract from the given function negative 1, because down means minus whatever unit. If they had said moves up by 1 unit, like we did in the previous question yesterday when we were doing trig functions, where G of X was given, it was 2 sine X, and then we are asked if the graph moves upwards by 1 unit, write down the new equation of the new graph. So we wrote it down as 2 sine X plus 1, because moving up means we add 1 to the value of Q. Remember, guys, that this is the standard form of our sine, cos, and tan graph as per the grade 10 syllabus. Because in grade 10, we only check at A, the coefficient of sine X, all right, and then Q, the constant, all right, which basically tells us 2 things. If Q is greater than 0 or positive, we are talking about a vertical shift up. If Q is less than 0, then we're talking about a vertical shift down. Okay, and then of course A has its own sort of like properties. When A is greater than 1, we are talking about a vertical stretch. When A is between 0 and 1, then we are talking about a vertical compression. And then when A is less than 0, in other words, when it's negative, then we're talking about a reflection of the function on the x-axis. Okay, guys, with that and more, I would love to share with you. That was our trig function section for the day. We will be doing more in future live lessons. I hope you guys enjoyed this particular live lesson. There are more things coming up in the next live lesson, of course, but we are just unpacking this topic, which is very, very basic and simple, one problem at a time. Okay, I will be uploading this particular session that I just did now onto my YouTube channel so that people can actually check it out if they want to, at their own time, at their own pace, and actually eat it up as they would want. But thank you so much, guys. It was great. Vienna, thank you so much for cooking yourself in the live lesson yourself. My good friends there, the Dawn, I'm sorry that you had to join in so late. PK, it was great to have you in the live lesson, especially considering that you came in and you just did the things. Guys, with the questions, you can go to your textbooks, man, and get questions. There are a lot of questions, trig graphs questions. Remember that I am trying to have people actually join my live sessions. Okay, and the way that I am able to pull people into the live lessons is to make sure that I have worksheets that basically appeal to certain questions that I would want to ask. So I don't want you guys screenshotting or screen grabbing what is yet to come, because that will make you not want to join my live lessons. And on top of that, it will make you not want to gift in my live lessons. Okay, and not to double tap on the screen so that there's visibility of my live lessons, and not to do other things that pertain to someone's growth on the platform as well. Because remember, guys, in as much as I'm doing this for free, of course, this is also for people to have the opportunity of actually learning and developing. So like I said, you have textbooks, you have past question papers, you have websites that you can download question papers to your heart's content, and you can screenshot those question papers and do them till your heart's content. I am just taking segments of certain of those question papers, and I'm utilizing them to answer and also help us to make sure that we know what we know and we know it well. So don't hate me, don't hate the player, hate the game. All right, and seeing as though this is your favorite host and channel, Maths is a Game, please guys, don't hate the player, hate the game. And on top of that, please love maths, because maths is a game and we need to play it so that we can pass with distinctions, we can fly and do amazing and phenomenal things in the world. Cheerio, tootles, see you again, have a great night and lots of love. God bless.